Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. You are given that for a certain insurance policy, loss X in 2005 followed the Pareto distribution with the survival function S sub x of x equal to 2000 over x plus 2000 squared for x greater than 0. For 2006, losses increase 5% due to inflation, and an ordinary deductible of 100 is applied. Find the expected cost per loss unconditional in the year 2006. And here's the solution. Let's write W for the amount paid by the insurance company in 2006. So we have W is equal to 0 if 1.05x is less than or equal to 100, because 1.05x is the new loss that increased 5% due to inflation, and 100 is the deductible. And otherwise it's 1.05x minus 100, that's 5% inflation increase and a deductible of 100 applied. Therefore, the survival function of W, of this new random variable for the payment by the insurance company in 2006, is equal to probability that W is greater than W, the survival function of W, which is the probability that, and that's of course only for positive values of W. But the random variable is positive with probability 1, and therefore we really only concerned with this survival function to find the expected value using the Darth-Vader rule. The value of 0 happens, of course, with a positive probability corresponding to the deductible, but we are only really concerned with positive W to find the expected value. Of course, the value of 0 happening with positive probability will still not contribute anything to the expected value because it's the value of 0. So anyway, what is the survival function? Well, it's therefore the probability that 1.05x minus 100 is greater than W. That's the same as probability that x is greater than W plus 100 over 1.05. Okay. Based on the formula we were given, this is the survival function of x applied to this W plus 100 over 1.05. So this is 2000 over W plus 100 over 1.05 plus 2000 squared. And we can simplify this by multiplying the top and the bottom by 1.05 and then simplifying somewhat. So it's 2100 over W plus 2200, the whole thing squared. And of course, the expected value is the integral of the survival function from 0 to plus infinity of the integral of 2100 over W plus 2200 squared dW. Well, that's equal to minus 2100 squared. That's what we get when we square 2100 as a constant number. And so this function we're integrating is really 2100 squared times 1 over W plus 2200, the expression W plus 2200 squared. And that function whose derivative is what we have here is 2100 squared over W plus, minus 2100 squared over W plus 2200. And we evaluated from W equal to 0 to W going to infinity. At infinity, it's equal to 0, and we subtract the value at 0, which is 2100 squared over 2200. And of course, we subtract a negative value so that it becomes positive. And that's approximately 2004.55, which is answer B. Please remember this is copyrighted material. The problem was created by me and belongs to me. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.